1961, Gelman and Yuval Neyman independently proposed a classification system called the Eightfold Way that separated the known particles into multiplets based on charge, hypercharge, and another quantum number called isospin. After the Eightfold Way was developed, it was noticed that some members of the multiplets were missing. However, as other particles were discovered, it soon became clear that the Eightfold Way was not the final answer. In 1964, Gelman and George Zweig independently proposed that the hadrons were not elementary particles but rather made of still more elementary particles. These hadrons are a class of particles that experience the strong interactions. So that Eightfold Way lead to the development of the quark model, in which all such hadron particles can be created by some fundamental entities called quarks. There are two general rules for combining quarks to form hadrons, and these are the barons and the mesons. Barons are composed of 3 quarks, and antibarons are composed of 3 antiquarks. These are fermions or half-integer spin, and mesons are combinations of a quark and an antiquark. Matter are made up of atoms. Atoms are made up of what? Protons, electrons, and neutrons. Electrons are elementary particles not made up of further elementary particles, but neutrons and protons are not elementary. They are made up of further elementary entities which are known as quarks. 3 quarks were proposed, named the up, down, and strange. Gelman assumed that there were only 3 quarks, but with time, it increased to 6. The names of the quarks are up, down, strange, charmed, bottom, and top. Up and down quarks have the lowest masses of all quarks. The heavier quarks rapidly change into up and down quarks through a process of particle decay. Particle decay is the transformation from a higher mass state to a lower mass state. And because of this, up and down quarks are generally stable and the most common in the universe, whereas the other quarks can only be produced in high-energy collisions. Quarks have various intrinsic properties including electric charge, mass, color charge, and spin. They are the only elementary particles in the standard model of particle physics to experience all 4 fundamental interactions, also known as the fundamental forces, as well as the only known particles whose electric charges are not integer multiples of the elementary charge. Quarks have fractional electric charge values, either -1/3 or +2/3 times the elementary charge depending on the flavor. Up, charm, and top quarks have a charge of +2/3, while down, strange, and bottom quarks have -1/3. Antiquarks have the opposite charge to their corresponding quarks. Up-type antiquarks have charges of -2/3, and down-type antiquarks have charges of +1/3. Two terms are used in referring to a quark's mass. Current quark mass refers to the mass of a quark by itself, while constituent quark mass refers to the current quark mass plus the mass of the gluon particle field surrounding the quark. These masses typically have very different value. Quarks possess a property called color charge. There are 3 types of color charge, the arbitrarily labeled blue, green, and red. Each of them is complemented by an anticolor, anti-blue, anti-green, and anti-red. Every quark carries a color, while every antiquark carries an anticolor. Spin is an intrinsic property of elementary particles, and its direction is an important degree of freedom. The spin value of up quark is +1/2 and -1/2 for down quark. Spin can be represented by a vector whose length is measured in units of the produced Planck constant. Antiparticles of quarks are called antiquarks and are denoted by a bar over the symbol for the corresponding quark. Each quark has an antiquark which is the same of the original quark except it has an opposite charge. The antiquark is written with a bar over the letter that is Q.